Hello and thanks for visiting our website, rebuilderinabox.com. Today we're going to show you the fastest yet most effective way to rebuild the ever popular 42 MT. If you have a tractor trailer rig, you probably have one of these starters. They fit Cummins, Detroit, Cat, just about everything. This unit is equipped with the 11-tooth most popular drive Bendix, Positorque Bendix. If you put a paint mark on it, you can count, spin it 11 teeth, which is the most popular one for Detroit and Cummins. Also, you can run into some 12 teeth. Also, you'll notice the rotatable nose. You can take these out, put the nose cone into any position you want. Also, you'll notice this unit is equipped with Del Carimi's OCP overcrank protection. It's just two little pins. This one's been damaged, it got dropped on it, so it's going to need replaced. If you try to overcrank, there's a thermostat on the inside, opens up these two pins so that the ignition switch can't make a continuity. Then when it cools back down, you'll be able to crank again. First thing we're going to do for ease of reinstallation is take a paint stick and put a mark on the drive-in rotatable housing and the lever housing, so that when you go to reassemble it, just line up the paint stick marks. What you're going to need to take the drive-in housing loose is a T40. Take these out, there's 6 of them. You're going to want to adapt it out to a at least a 1/2 inch. Here's an example of the tool that works really well. You can see the T40 5/16 deep well 1/4 inch drive, and then you're going to need to adapt the 1/4 inch to 3/8 and then the 3/8 to 1/2 inch. You can use a breaker bar or a 1/2 inch impact. Notice how the entire unit is clamped inside a vise and tightened down for safety purposes. Then you're ready to tap the nose off. And on this particular model, there's no spacers or snap rings between the shaft and the end of the drive. Next, looking at the back of the solenoid, we're going to want to take this bolt and this bolt out and remove this motor strap. You're going to need an E8 socket, star socket, whatever you want to call it, size 8, and a short extension. There's the strap. Next, we're going to remove the ground wire and ground bolt assembly. The top of the wire that goes from the ground side of the solenoid down to the ground bolt on the motor is held on at the solenoid by a 3/8. Take that off, take that loose, and then remove your ground wire. Then you need a 3/4 wrench. Put a couple drops of oil on the threads so that as you back the nut off, which is half 13, you don't do any damage, because if at all possible, you want to try and reuse that stud. Then taking the rest of the hardware off of the stud, we have a lock washer, a steel flat washer, and the fiber insulator. Next we're going to remove the solenoid mounting bolts. There are 3 of them holding the solenoid on in a triangular shape. You're going to need the E8 that we used previously to take these 2 bolts off. They're the same bolts that hold those 3 on, so get those out of there. Then you can start to pull this off. And if you need to, you can take a couple screwdrivers and wedge them in around the sides if there's a lot of rust in there. Looking at the solenoid mounting area from the drive end of the housing, you'll notice there's a circular plug area right here. This is like a freeze plug that threads in clockwise with clockwise threads on it. Take a screwdriver or a small chisel and a hammer, and you'll see the raised up portions on it. Just get it coming out of there by tapping counterclockwise, and then unthread it. And down inside that, you'll see a 1/2 inch aircraft nut. When I'm removing that 1/2 inch aircraft nut on there with the neoprene insert, the best thing to use is an impact, because the rod that it's threaded to will rotate as you're trying to move it. Now we're ready to pull the solenoid off. You can see on this particular model, the plunger assembly is built in. We usually don't sell them like that, and a lot of them don't come this way. The plunger and the solenoid are 2 separate pieces, but they interchange. Here's a shot of the 2 separate pieces, which most commonly you do run into. The solenoid and the plunger assembly are 2 separate pieces. There's the threads where we just took the aircraft nut off of, and it just simply goes in there like that. Now we need to remove the 4 E8 bolts that are on the back. Then we're going to take a hammer and a small drift or an extension or something and tap this back plate off of here. It comes off a little bit tough if there's any rust in there. It's almost like a compression pan because there's an oil ring. Inside you can see the thermostat portion that comes open when you overcrank. It's just held on by a slide-on C-clamp, which you can remove. Now looking at the back side of the starter, we have a couple parts to remove and save. This is an oil seal, an insulator which fits inside the hole in the back plate, and the back side of an insulation that goes on the grounding stud so that you can have positive ground. This is a metal washer, which is important to get back in there. It's just a spacer. Let me just explain a little bit about what we got here. With the motor terminal at the top, we have 2 ground brushes 180 degrees apart and 2 hot brushes 180 degrees apart. The 2 hot brushes have also 2 field leads coming up to them. With the motor terminal on top, you'll see the 1/4 inch head, if it's original bolt, holds the brush wire and the ground wire in. Remove it. Here you see the brush leads and the ground terminal lead. Loosen the vise, rotate about 90 degrees, and then take out the other 1/4 inch screw. And that holds in the field lead and the brush itself too. Then turning the starter completely upside down, you'll see the other ground screw, 1/4 inch lead and brush. Once you take that off, then the whole stud and lead assembly comes off. Rotate it about another 90 degrees and you'll find the 4th and final 1/4 inch head to take loose. Underneath that is the dual field leads and the brush leads. Now we're going to take a pair of needle nose pliers and pull straight back on the brushes to remove them. There's 2, 3, and 4. Now you'll notice how the brush holder assembly, the metal bracket itself, is ready to come off. Right where the solenoid strap went in, there's an insulator. This is a plastic one. Sometimes they're a round rubber boot. Remove that. Looking in from the drive end, we need to take out 5 of the E8 headed bolts. There's 2 here, 2 on the other side, and 1 on the bottom. You'll be using an E8 star socket to take those off. One time we couldn't find our E8, so we used a regular 1/4 inch 6-side, and it seems to work amazingly well. Now we're going to tighten the housing in the vise like it has been, and we need to get this lever arm housing out. You can start by tapping it loose. Don't hit with a lot of force, just kind of tap it. And if it doesn't want to come because of the oil seal, take a screwdriver and split it. Now when this comes off, the Bendix and everything comes with it. The drive, leave the armature in, so hold the shaft where it is, and just take the Bendix and the lever arm housing off as a unit. Then we're going to grab the armature by the shaft with 2 hands and flip it upside down so that the metal spacer falls out. Now we're looking down at the drive that's still in the lever housing. Just pull up on the drive and there's a thrust washer, a fiber washer underneath. All that really does is keep the Bendix from making a grinding noise when it goes back against it. It goes directly underneath that so that when the Bendix flies back, it doesn't rub metal to metal. In review, here are the major components disassembled of the 42MT starter. The rear housing with the thermal cutoff, the armature, the drive or Bendix, brush holder, plunger, which goes inside the solenoid, lever arm housing with fork, and the field housing. Last but not least, the rotatable drive-in housing. Reviewing over the smaller parts, we have the 4 brushes with the 4 brush screws, the solenoid plunger, and the nut. The 4 bolts that hold the back plate on, and the 5 bolts that hold the lever arm housing to the field housing. The grounding stud that goes through the back plate, and the 3 insulators. The inside one with the square fitting on it, the middle one, and the outside one. The 6 bolts that hold the rotatable drive-in housing to the lever arm housing. The large spacer which goes between the lever arm housing and the armature shaft. The small steel spacer which goes between the back plate and the armature shaft. The freeze plug which goes in the lever arm housing, and the fiber washer which goes underneath the bendix, between the bottom of the bendix and the lever arm housing. Solenoid hardware, we got the ground wire, 3 bolts that hold the solenoid on, and the strap that goes from the motor terminal on the solenoid to the motor terminal on the field housing. Before we begin the cleaning process, we recommend continuity tests on the armature and the field housing. If you have a MIGger or a power-driven continuity tester, this is the time to use it. You can also use a regular ohm meter. The test is like this. The commutator has to be completely insulated from the body of the armature itself. The shaft and the body are connected, so you can use either point for a test, but the point is that the commutator has to be insulated from the body of the armature. There should be no continuity whatsoever. The same thing with the field housing. All we have to worry about is that no copper is touching any metal. So if you have a MIGger or a continuity tester, you put 1 lead on the copper and 1 lead on the metal. You can put it on either lead, and you can ground it, check for ground anywhere on the metal, and there should be no continuity whatsoever. Sometimes dirt gets in it. You can wash out the dirt, but if you read any type of ohms from here to here, that should be considered a failure. We've used tinted ignition sealer and red insulating varnish to paint the inside of the housing. You have to put masking tape over the leads so you don't get any overspray where the brushes are going to be hooked up. Notice how we've used a tinted ignition sealer on the metal part of the laminations to keep the rust off. The shape this commutator in is fairly typical. It doesn't really require any major cuts or sanding, just a good cleaning with some fine sandpaper or Scotch-Brite. You want to just be careful and look at the end of these where the risers come up and make sure that there's no separation in between where the external winding comes in and where it goes back down to the internal part of the armature. It should be solid looking, all one piece. You shouldn't be able to visually see any separation. Where they start to separate, you'll see a little bit of a burn mark, or maybe the outside has been burnt and it's starting to lift up. Those are signs that you have a bad armature. But this one here, the condition that this one is in, would be considered fine. You just also want to make sure that nothing's raised up and burnt along these bars here. Sometimes when you got to jump them with jump equipment in the cold weather and they have to spin real fast to get everything going, they'll fly open in here and you'll see burnt marks. If you do have a lathe or access to a lathe, you can always file the commutator down just to make sure that if there's any pitting or any scratches, that you would smooth them out. you can see where we recommend the tailstock to be chucked up. We're going to use just an ordinary file. And this is 80 grit sandpaper. Put the armature in a vise and use the sandpaper to sand the short side of the shaft in a circular motion. The long portion of the shaft should be sanded in the direction that the Bendix travels in and out, so that you don't have scratches that contradict the travel of the Bendix bushing. Then we're going to use the wire toothbrush to clean all the dirt or any imperfections out of the spline. Finish with 4 or 5 drops of oil on the entire area and spread it around. Now we're going to be removing the rear bearing from the back plate. And there are 2 different methods that you can use to do this. One is to drill 2 holes in the back, measure over 9/64 from the edge, then 27/64 on center from the center of that hole, and drill 2 1/4-inch holes, so that when you look down in the holes you can see the bushing on both sides. And you can drive them out with a long center punch that's flat on the bottom. But when you do this, you want to set the inside on a 15/16 deep well, so you're not disturbing the construction of the back plate itself. The other method for bushing removal works a lot better, and it's the preferred method, especially for doing multi-units at a time, is to get a tap that is approximately the same size that would thread into the bushing itself. And you begin threading it into the bushing, thread it all the way to the bottom, and when the bottom of the tap bottoms out on the aluminum back plate, it starts to pull the bushing out, and it works very well. Put the rear plate in an oven for about 20 minutes and heat it at 350, and the rear bushing will almost fall right in. If you need to, you can give it a little help with a 1/2 inch. We're going to use the armature shaft to make sure that the bushing is pre-fit and it doesn't heat up by fitting too tightly. All you do is put a little bit of grease down in the bushing, put the armature in a vise, and tap it on. Then you can spin it around and tap on the outer diameter to make sure that everything spins freely. That means the bushing is broken and ready to install. We're going to be using a large screwdriver with a long handle on it to pry out the rear seal in the lever housing. We're going to place the lever housing upside down in a vise and tighten it up lightly so that we can remove this shaft seal. Now we want to drive the bushing or the bearing out. We'll be using a medium-sized 1/2-inch extension. Then we're going to set the bushing down in there and tap it down with the same tool. Then set the seal on it. This is a 15/16 deep well. Then put the armature in the vise and make sure that the bushing is broke in. You want to have a little bit of play. If you don't, you can tap it, spin it around, tap it, put some oil in it, working back and forth, and make sure that you got a little bit of wobble there. Also, to do the rebuild properly, we have to change the fork that throws the Bendix out. Mostly they just wear a little bit underneath, and this one really isn't, but most of them are because of spring tension. So it's just a good idea to go ahead and change all of those. The pivot bar on this side is held on by the clip. Just hit it with the round side of your ball peen hammer and bust it out. When you're putting the new fork in, make sure that the cross member, this is the bottom of it, and this is the top of it that has the cross member on it. Make sure that the cross member, looking at it from this view, is up. So you can just put it back in there, and then put the pivot back in and put the clip on. Putting the snap ring back on, just be extra careful that it goes all the way down, and double check that it is in fact in the groove that it's supposed to go in. We always put a couple drops of oil inside on the pivot point. We're using a 3/8 medium extension to drive the bushing and reinstall the bushing out of the nose piece. Now we're putting the bushing back in. We want to use a generous amount of red Loctite and the 1/2-inch. We recommend taking a chisel that's been sharpened up and stake the drive end of the casting so the bushing can't work its way back out again. Here you can see the marks that we made with the chisel, and the idea is to try and get some of the casting to go over to help hold the bushing in place. Also, the staking will help hold the bushing from spinning. Then we're going to place the armature back in the vise again and break this bushing. Break this bushing in by turning it on and spinning it. Tap it around a little bit. To get it to where everything feels nice and smooth. This bushing has a lot closer of a tolerance than the middle bushing. You don't want very much wobble on this one here. Also, you want to double check and make sure after you're done breaking it in that the bushing itself is still fixed firmly into the casting. Clean up both leads inside and out with a small piece of sandpaper, and then put a small amount of white lithium grease on them. We're going to do a visual inspection of the inside wiring of the housing. Take a look and make sure that the jumper wire is tucked behind the insulator in this area here, and make sure that the leads coming up on both sides are pushed back away so that they can't rub onto the armature, and look down through with your favorite light band or light wand so that you can 180 and 180 both sides, looking at any type of interference or any type of a intrusion in there that could possibly rub on the armature. Now let's do some assembly. Put the field housing in the vise. Put the armature inside the field housing. Notice that the copper field lead, the motor stud, is up. The armature should be able to slide in and out freely. Place it just so that the riser is right about in line with the top of the field housing. Take the large, thick metal spacer and place it over the shaft on the drive end. Take the new gray fiber washer and place it underneath the fork in the lever arm housing. If you want to, you can use a little bit of adhesive between the housing, the metal on the housing, and the fiber washer, but it's not a necessary step. For quiet running, smooth operating, we're going to place a small amount of white lithium grease on the nodes of the fork. Now we want to put the positive torque into the lever arm housing by raising up the fork and putting it in just like that. Then we're going to hold the bendix in place with one hand, hold the lever arm with arm housing with the other hand, and slide it onto the shaft. You want to double check before you do this and make sure that there's plenty of oil on the shaft, especially on the straight splines. Looking at the housing from the drive end, you'll notice that one of the holes is unthreaded and the other 5 are threaded. So when you install the lever arm housing, the part of it where the solenoid bolts on goes straight up with that. It's almost in line with the copper terminal on the field housing at the other end. Prepare the 5 bolts for installing on the lever arm housing. You can wash them in solvent, spray them down with WD-40, whatever you want to do with clean them up with a wire brush if they're rusty. But the main thing is to put at least a couple drops of oil or some white lithium grease on them so that they don't become galded or rusted in the housing itself. Now when you tighten these up, you're going to want to remember that the seal in here, the rubber seal, fits pretty tightly, which also you can put a little bit of dielectric grease or RTV around that. But when you tighten these E8s up, you're going to have to use a diagonal pattern so it doesn't bind, because it will definitely bind. You have to tighten one up about halfway and then go 180 and tighten that up halfway, and then work your way around to get everything in there squarely so that it doesn't break one of the bolts or bind up when you're trying to put it in. You'll notice that there are 2 circular lineup holes on the new brush holder assembly, and also you'll notice that there are 2 openings Both things are 180 apart. Here, here, and here, and here. You also notice the roll pin on the housing. There's one here, and there's another 180 down on the bottom. Here we've placed the new brush holder assembly onto the housing and commutator. It doesn't have a top or a bottom. As long as you get the holes on the roll pins, top and bottom, you're lined up fine. Tap it down in so that it's laying flat on top of the housing. When installing the brushes on the 42 MT, make sure that the raised up portion is up. The flat side should be down against the brush holder assembly. Take a pair of needle nose pliers and roll the spring back. Insert the brush and put the spring squarely and on the middle of the brush itself. Repeat the process 4 times so that all 4 brushes are installed. Now at this point, it's best to get an ohm meter or a continuity tester of some sort and run some continuity tests for quality control purposes. We're going to put 1 lead of the ohm meter on this roll pin, acting as a ground, and then we're going to go around to all the brush holders and make sure that none of them are connected. So everywhere, the commutator, all the brush holders, and both field leads coming up, there's 2 of them here and here, should all test for no continuity. It should be open from ground. The case of the starter itself and the shaft are connected, but every brush holder, all the brushes, and both field leads are open. I'm going to bolt down the 2 brushes with field leads coming out first. Find both field leads, lay the one on there so that it lines up with the 832 threaded hole, and then lay the brush wire down on there with the flat side down and put the screw in. We recommend using the original equipment 1/4 inch head 832 screws when you reinstall the brush screws, because they're a higher quality than most of the Chinese new ones and less likely to strip. Tighten it down as tight as you possibly can without stripping it, and go back and double check yourself to make sure that you did in fact get that as tight as it would go. If it does strip out, all you have to do is get an 832 nut and put it underneath and retighten everything, instead of just trying to replace the whole brush holder assembly. Just simply get an 832 nut and put it underneath, and it's pretty easy to get started on there and retighten everything. When you're done, make sure that the field leads coming out of the field are up high enough so that they don't just pry up on them a little bit with a screwdriver, so that they can't rub internally where the armature would rub on them. And make sure that there's clearance between the hot lead and the ground spring, because this is a dead short if these 2 touch each other. Same thing with the other side. Get it as tight as you possibly can without stripping it out, and then take a screwdriver and pry up on the field leads down on the bottom so that they don't rub on the armature, and make sure that there's no way that anything from here is touching the ground spring. Now looking at the ground post assembly, you can buy these new. Normally, if the threads are in good shape, we are able to use these over. You can clean these threads up with a wire toothbrush. We don't recommend a electric wheel because they're copper and they're real easy to ruin the threads using an electric wheel and cause yourself headaches putting the nut back on. So put the just use a wire toothbrush to clean this up real good. Inspect the insulation and the connections at either end, and inspect the connection where the wire goes onto the post for fraying. But you can also clean up both sides of the terminal connectors. Put a couple drops of oil on here so that you can get the nut on easily. You'll notice there's a long side and a short side. When we go to put it on, the short side with the field housing, motor terminal up, the short side goes up. Here you can see the field housing with the motor terminal up. We still have 2 ground brushes to put on. The 2 field leads, the 2 hot leads, are already bolted down. So when you put this on, the short side goes up. Here you can see the empty terminal. They mostly give you 2 threaded holes to choose from, and you can use either one. You can put them both on the back one, both on the front one on each, as long as everything is not touching where it shouldn't be touching. Generally, I recommend that you put them both on the same hole, the closest one. Now we have everything screwed down. All the leads are screwed down. You can see the short lead at the top. We're going to go around and push all 8 brush wires down flat so that they cannot come in contact with the shell. Then at this point, you want to double check with your ohm meter to make sure that the roll pin has no continuity with anything. It shouldn't have any continuity with either side of these or either of the hot brushes. The shaft will have continuity with the roll pin, but all the other points are to be open from the roll pin. Then we're going to put the metal spacer on the shaft, the square insulator goes down on the square fitting on the ground post, the round insulator goes on next, and then the rubber water seal. If you have OCP, over crank protection, we're going to be placing that on there now. Place this portion of it, we're going to black tape this on to the negative terminal parallel to the long lead that's going on there. This side, the flat side, goes towards the outer part, and we're going to stick it in there, and this is upside down now. The field terminal on the housing is on the bottom, so this is the long side of the ground post assembly. We're going to stick it in there parallel and black tape it on. So we're going to black tape it on. This is the outer flat side, goes towards the outside, and put a couple drops of oil on this seal ring so that it's easier to get it into the housing. You'll find the 2 grooves on the inside of the back plate. Those go on to the roll pins on the back of the starter. One trick to get these on easily is take some dielectric grease or white lithium and rub it around the outside lip. Make sure that the steel spacer is on the end of the shaft, and these go on the roll pins. Put the 4 E8 bolts in and tighten them down. Then we're ready to put on the insulating washer, the metal flat washer, and the nut. Hold out on the stud as you're turning the nut on so that the square fitting holds it in place. Then we do a final test with our ohm meter. One side is hooked up to ground. Neither post, the hot one going in or the ground one coming out, should have continuity with the case. The field lead and the ground terminal will be connected together. Silicone or lithium-based grease will help the plunger assembly go into the hole. We're going to install the plunger into the lever arm housing. Once you get it through the hole in the clutch arm fork, screw the aircraft washer down on until it's flush with the top of the plunger. Then continue turning 1.5 turns. So after the plunger is installed, find the shortest stud and that goes on the bottom for the motor terminal. Then put the 3 1/4-20 number 8 bolts in. Doing a meticulous job of buffing is particularly important with the strap in this area here, top and bottom, and the bolt that goes down into the field housing lead has to be extremely well buffed on the threads and the inside flange of the bolt. Then coat them with a generous portion of either dielectric grease or white lithium grease. It is also very important to lubricate the face of the nut on the motor stud where the strap's going to go and the threads with either white lithium grease or dielectric grease, silicone base. We do not recommend the use of lock washers in either location. Looking at the back of the starter, the ground wire goes from the left side of the solenoid down to the ground post. Tap the nose cone back on so that the mark on the top of the housing lines up with the middle of the casting behind it. Reinstall the 6 bolts that hold the nose cone on. To test the starter, lay it flat on the ground with the solenoid towards you, because when you engage, it's going to kick back this way. Put your hot lead on the solenoid post and your ground lead on the ground post. We're going to be using a thumb depression switch to activate the starter. The leads from the thumb depression switch go on the hot wire and down to the S terminal on the solenoid, which is the other little terminal opposite the ground wire. We suggest placing the starter on a rubber mat or carpet to reduce walking or vibrating. Put your foot on it. First thing we're going to check is a series of short solenoid blasts, which tests the pull-in current and ejection ability on the Bendix. So we want to see the Bendix go in and out quickly. And we're just flicking on the thumb switch real quick. And you can see that this is good because it kicks in and kicks out. Now we're going to spin the starter up and listen to it spin up. It should run smoothly and sound like this. Only run for about 10 to 15 second intervals. Now we're going to take a hammer and tap it on the sides and on the ends a little bit to see if it causes any dragging. Also, what this does, it helps seat the brushes. The next thing that we like to check is called pinion clearance, and that is when the Bendix is engaged or out and the starter is spinning, there's a distance between the front of the nose cone and the top of the Bendix. This is called pinion clearance. The Delco website says it's supposed to be between 0.328 and 0.390. We do not recommend measuring this thing manually. Just take a rough estimate by eye. It's adjustable by the setting of this nut, but you have to use an impact wrench, because if you just use a regular socket or a wrench, the center of the shaft will spin. But if you want to pull it out a little bit farther and tighten that up, or back it off and then run it again to make sure that your adjustment took hold. All we have left to do is put the new O-ring on the plug, install the plug, and then take a screwdriver and a hammer and tap it tight again, and you're done.